Why is that happening? Why is that happening? Oh, wait, am I good now? Am I good now? Did I do it? Can you hear me? Mic check, 1, 2, mic check. I tell you guys. Let me get over to the WQAD page. Oh, this has been a journey. Sorry, guys. I know how annoying that was. Let me get over to the WQAD page. Oh, this has been a journey. Sorry, guys. I know how annoying that was. Woo, we're live. Okay, so the problem was the headphones. I did need headphones in. Thank you to meteorologist Andrew Stutsky for helping me in a time of panic. All right, we're good to go now. Man. Whew, okay. That was only mildly embarrassing, but it's okay. We're back up and running and it sounds like our audio is good and now we're good to go and we can jump into this thing. Thank you for standing by. That is I know how annoying it was to hear that. So, thank you to Andrew. Okay, if you are now just joining me, we're going to dive in and we're going to take a quick look at the forecast for today. Really, the only advice, find some time to get outside, take in the sun, take in the temperatures. 78 degrees for an afternoon high in the middle of October. Now, it is going to be gusty. We do have a wind advisory in effect until 7 p.m. tonight. 45 miles per hour of wind gusts. So, yes, definitely breezy. I can hear it outside, I can see it outside, but still a really nice day for us today. And then look what happens tomorrow. We have a cold front, not going to bring any rain, so we'll stay dry tomorrow, but it is going to lower our highs by 20 degrees. So, definitely going to be chillier tomorrow, definitely going to need those jackets tomorrow. And then next week, we get even chillier as we drop down to the upper 40s, low 50s. A couple of rain chances as well there. Um, as always, be sure that if you have a question pop up during today's lesson, it doesn't even have to be about the lesson today. It could be about weather in general, anything that you can think of. Be sure to put them in, and we will look at the comments at the end of the lesson and say hi to people, give you answers to your questions or find out the answers to your questions, whatever you need as well. Andrew's not joining me today. He is filling in for the James Sahara tonight. So I am taking it on nice and solo. Okay, so let me work on getting this PowerPoint up. I'm going to tell you. All right. Here we are. All right, we are in action now. So, today's lesson is all about air pressure and why it is one of the most important things when it comes to weather and understanding the weather, and when it comes to forecasting, especially. Pressure systems are very important. All right, let me make sure that we're on the right. Okay, today's agenda. What is air pressure? Oh, of course it's out of, just bear with me here. Review of surface maps first, and then we get into what air pressure is, why it's important for weather, and then, of course, your questions and your comments answered at the very end. We will go through all of that. So last, or 2 weeks ago, we talked about surface maps, and surface maps share a ton of information. Very useful, gives us a nice snapshot of the entire United States of what is happening right now. Also, it can help predict exactly what's going on in the future, and you can see some future maps as well, but really what we use is that snapshot of right now. What is happening right now? They can show wind direction and speed, show humidity, they show fronts, temperature extremes like we're seeing today, and as well as where are those points of low and high pressure on the maps. There is another picture. We got the one from just the other week, I believe, where we had a cold front come through bringing us showers. That's not the case today, but tonight we're going to get a cold front. So we have on those station maps, we do get all of those little station plots. And these are the important tools to show us what is going on. They show pressure on them, and that is how they are helped to be plotted of where those center points of low and high pressure are located. And then there is a snapshot of a map from September 30th. We had a nice front coming through. We had a warm front coming through. Kind of a similar situation to what is going on today, which I do have a picture of the map from today. So we will see that coming up in just a moment. So diving in, what is air pressure? So air, let's get up with the composition of what air is. The atmosphere is made up of colorless, odorless gases. The most abundant gas in the atmosphere is nitrogen. And then, of course, the most important for our lives, oxygen, which is at around 21%. So just between nitrogen and oxygen, we are already at a 99% composition. Then we get to argon, which is just under a 1%. And then the 0.04% that's left is others, including carbon dioxide, which is naturally in the atmosphere. But then we get into where we put in more excess. That's a whole different story. But it is naturally there, and it's good for the environment in its natural doses, not in excess. So we want to put that out there. But the definition of air pressure is the weight of air molecules pressing down on the Earth due to gravity, which we know gravity is the reason why we are not floating off into space. We like gravity. Now let's talk about the weight of air, which is something that I actually just learned through doing these lessons. The weight of air actually weighs a ton, literally. A ton of weight is weighing down on the Earth's surface at all times. At sea level, which is 0% altitude, when you're standing at the beach and you see the ocean, you are standing at zero, or at sea level. Air pressure weighs down on you 14.7 pounds per square inch. So only about this big. This big. You have 14.7 pounds of air weighing down on you. That's a lot of weight. And now when we talk about that, just imagine like you're standing here, you got an entire column of air weighing on top of you all the time. So when you talk about a square foot, which we humans generally take up about a square foot, you have over 2,000 pounds of air weighing down on you if you're standing at the beach. Now, why don't we feel this weight? Why doesn't it feel like we are being crushed by the atmosphere? Well, that is because humans, our bodies, were actually really cool. We have these things in our bodies called lungs. We are taking in the air around us. We're breathing it in, and our bodies actually take that air that is breathing in. It is equalized within us, so the pressure inside of us is actually equalized to the pressure that is around us. So that is why we are effortless as we can raise our arms, we can raise our legs, we can walk. We don't feel anything on us because our bodies are equalizing with the air around us. So, very interesting to say the least. You're not feeling that 2,000 pounds of air on top of you. So, pressure with height. We know that pressure decreases with height. When you get in an airplane, you've probably talked about pressurizing the airplane, making sure that the pressure inside of the airplane is comfortable for humans because we cannot stand the very low pressure that planes fly at. So the higher you go up in altitude, the lower the pressure gets because you have less of that weight weighing down on you. So the higher you get, the less column of air that you have that is weighing over you. in there. I just talked about it. I spoke ahead of myself of the words on the PowerPoint. So yes, this is because the column of air above you is smaller, so there is less weighing down on you. How is it measured? How do we measure it? We use this fancy tool called a barometer. Now, a barometer can be there's many units out there that can measure pressure. We have hectopascals, we have pascals, we have inches of mercury, we have millibars, which is what we use right here. Meteorologists, we study in millibars, which is the metric unit, I believe. And then the United States, they use units of mercury, which I don't even understand units of mercury, but that's what the United States uses because we're on the imperial system. So yeah, we use millibars, which sometimes you will hear that, especially with hurricanes. You'll hear about the pressure being like 930 millibars, which is extremely low, very low pressure, which hurricanes do have. But so when you hear millibars, you will know that that is just a unit of pressure. So why it's important to weather? It is very important to weather. Air pressure changes with height, but it also changes with temperature. So it's very influenced by temperature as well, which weather, huge thing when it comes to temperatures. Meteorologists monitor these changes, and it can be very helpful with forecasting. And have you heard us say, we have an area of high pressure over us today, or we have a low pressure system moving in tonight? You've heard those words be used quite a lot. Sorry, I am just looking over. All right, cool. So, yes, you've heard us say high and low pressure. So here is a return back to the surface maps. This is actually a snapshot from this morning that I took. We have a warm front moving in. That is bringing in that nice warm air to us today, but look where it's going behind it. Let me see if I can get my nice little pointer here. Oh no, it doesn't want to use it. I forget what I use. Oh, here it is. Okay. So we have this pointer right here. We got a cold front pushing in behind the low. That is expected to arrive tonight. That is going to bring the cooler temperatures as we get into tomorrow. So you can see a lot of H's and a lot of L's on these maps. So we have one right over here to our north. We have another one over North Dakota. We have a couple of H's over here along the Appalachian Mountains. We also have a couple of H's over here in the desert southwest. So those are all indicating and showing us where areas of high and where areas of low pressure are on the map, which are very useful because they can show us where we're seeing lots of nice, clear, sunny skies and where we are seeing a little bit of rain, maybe some wind happening around the area. So low pressure, what causes areas of low pressure? Well, the atmosphere, like we've said multiple times, it is in a balancing act. It is always trying to be in an equilibrium. When we get an area of low pressure, well, how do we rebound from an area of low pressure? We got to bring in high pressure so we can get that nice equilibrium that the atmosphere wants. So it's always trying to balance those major temperature contrasts as well, which also affects pressure. So like today, we are getting very warm. Well, we're going to get very cold. So we got a low pressure coming through, trying to balance these different contrasts. That is also why we see warm and cold fronts attached to only areas of low pressure. We don't really see them attached to areas of high pressure. Areas of low pressure could tell us we could see rain, we can see storms, we could see clouds. So why is that? So this is just a very simple picture of what is happening around an area of low pressure. We have counterclockwise movement in the northern hemisphere. It is opposite in the southern hemisphere. But in the northern hemisphere where we live, it moves counterclockwise and into at the surface. So at the surface, it is going in and counterclockwise. Well, all this air that is being pushed in, it has to go somewhere. It's got to rise. So now we have a rising motion. When we have a rising motion, we got lift in the atmosphere. So we need lift to form clouds, storms, and rain. Now today, we do have lots of sunny skies, but that area of low pressure is bringing rain that is far off to our north. So now we get into an area of high pressure, which is Usually what brings us the nice, beautiful, sunny conditions. But what causes area of high pressure? As area cools off in a region, like we are going to tomorrow, we see high pressure systems form. Again, trying to get a nice balance in the atmosphere because we just cooled off thanks to a low pressure system. Now we got to bring in highs so we can get some nice sunshine, we can get some nice warmth back into the area. So as air cools off in a region, we see the high pressure system form. This is because cold air sinks, it sinks, and it's very dense. Areas of high pressure tell us we're going to have clear, we're going to have fair weather, lots of sunny skies in the region. So why is that? Well, in an area of high pressure, the air at the surface is moving clockwise now. So it's moving clockwise and out instead of counter and in. It's going clockwise and it's moving out of the region. Well, now all this air is being displaced at the surface out. It's got to replace some of that air from above. So we have sinking motions going on in a high pressure system. Well, that means we don't have lift. We don't have that lift that's going to be provided for some cloud development, for some rain development. So we don't have that lift. So we get some nice, clear, sunny skies that we all know and that we all love, I am sure. So why do they spin? So you heard me talk about the opposite. It happens in the southern hemisphere. We have something that is called the Coriolis effect. The Coriolis effect is a product of the Earth spinning on its axis. So we all know about the Earth. It is spinning on its axis. Well, the Coriolis effect, as we get away from the equator, it deflects that air because the Earth is spinning. So we get that deflection off. So that is why when we see those pressure systems and we get that nice intense winds that happen around them, it is deflecting that air and it's causing that spinning motion. And I have my favorite website to show us. So let me bring up my favorite website. You'll probably see this quite a few times. This is a very cool website to look at. So this is called earth.nullschool.net. It is a current map of the winds around the entire globe. So you can kind of mess with this and see all the winds. We can even change as much as temperatures. So let's actually put on temperatures. Okay, because we are warm. So let's go in to where we are. So right here, putting a little dot at where we are. Actually, we are right here. So the Quad City region is right there where that green dot is. You can see we got some nice warm air. We got some winds coming down from the south. And then we got some cold air that's going to be brought in because we're going to get that cold front, which is riding along right there. A lot of information on this map. Okay, but what I wanted to show you is one of the areas. We have a very, very, very large area of high pressure happening right off the Pacific Ocean. It's right there. You can see it spinning counterclockwise right there. But as the balancing act always comes into play, right behind it, we have a nice area of low pressure happening right behind it. So we have an area of strong high. Now it's got to compensate. We have an area of very strong low pressure just right off to the west of it. So you can see it spinning. I could stare at this map for hours and hours and hours and hours, but obviously we're not going to do that. Again, you can literally Google search this and just go to Earth Null School, put it into Google, the first one that comes up. You can just play with this map. I always do. It's a fun little tool, especially when there's a hurricane. When there's a hurricane, it's actually very cool to play with. All right, moving right along. Winds. This gets into a very, very nice topic, especially for today with winds. So, pressure differences causes winds. We have we get that air to be set in motion because if you were to look at the atmosphere from a profile view or like a landscape view as an entire whole, if you saw areas of high and low pressure with temperature differences, the air would kind of do this. So it's kind of riding along some slopes. So air moves from areas of high to low. So it's kind of moving along that slope, if you know what I'm saying. So air, again, flows from high to low. And then the tighter that gradient, the tighter that we get that gradient, the faster the wind's going to be. Like today. So we get into today. There is a closer little picture. Do you see these lines that are going on right here? We have these red lines, and they're pretty tight together. Those are areas of equal lines of equal pressure. The tighter those lines are, the more fast that we will see those wind speeds happening. So today we have a perfect example of what we call a pressure gradient force. So we have a warm front pushing in, we're going to get a cold front behind us, which brings us to the next point. Not only can pressure systems show us about winds and kind of what type of weather we're going to see, we can kind of get a little bit of a general idea of how those temperatures are going to trend over the next couple of days as they move in. So on this picture, let me get this. So we see extreme sway. So on this picture, we have an area of low pressure over here. So this is moving counterclockwise. We have an area of low pressure to the left. We have another one moving counterclockwise. So the middle, to compensate, trying to balance, it develops an area of high pressure moving clockwise. Well, this is filtering in a ton of cold air. So like tomorrow, we're going to filter in, once we get behind that area of low with that cold front, we're going to filter in some cold air, as well as probably move in an area of high pressure, which is going to keep our weather quiet as we head into the weekend. And then to compensate behind it, develops another low pressure. But when you're in between a high pressure and a low pressure, you're getting both that southerly wind influence. So then we know that temperatures are going to trend rather warmer than they were the day before. So it's just a lot of general consensus to be able to just get a snapshot and be like, okay, what is going to happen? How are we going to see things move into the next day or so? It can show us a lot of information. Pressure is very, very, very important. And again, that brings us to the end. This was a very short lesson, obviously, because I am on my own and I don't have Andrew's brain to come help pick apart some of the things, but we will get into your questions and comments. And again, thank you for sticking by me through the technical difficulties that we just encountered at the beginning of the lesson today. So let me get into your comments. Let me pull this up. Okay. Comments. Here. Okay. It's been a long time since I've done this on my own. Okay. People can hear me. Oh no. Where did that go? Come back. Come back. No. Where'd it go? Facebook's not being my friend today. Okay. Okay, I just see a lot of people just saying they can hear me. It's better. So thank you for that. I will go check my page real quick just to see if anyone is commenting on there. If not, I will let you guys go. Again, thank you for standing by. I know it was a little rough. Nicholas on my page, thank you so much. Thanks for the presentation and nice job, he says. We appreciate the feedback. I have a couple of my friends from my previous meteorology major asking me difficult questions that I'm absolutely not going to answer. They are trying to be funny. Good laugh, guys. Thank you for interacting with me, though. Okay, so that is that. Everyone enjoy your Wednesday. We will be back next week, and I believe next week's lesson is all about clouds, which is a very exciting one. I was going to have an experiment for today, but the experiment didn't turn out because I didn't have the supplies to do so. But there is an experiment with clouds, and I do have those supplies always on hand. So we will have a super cool experiment to do with the cloud lesson. So get ready for that. Again, thank you for joining me. If you guys have any questions, be sure to shoot me or Andrew an email. And also teachers, if there's any teachers or anyone who knows a teacher, Andrew and I are doing virtual Zoom meetings with classes, and we absolutely love doing them, and we would be happy to do so. You can just reach out to us through our emails. Okay, everyone, have a great Wednesday.